Okay, so now that we have done network segmentation, I'm going to introduce the labs, and we are going to cover the two labs that are related to network segmentation. Again, if you're watching this self-paced, you might or might not have access to the labs. So feel free to follow along with me, or again, if you have lab access, feel free to pause when I explain the problem and try to figure it out before watching me go through the solution. So this is the scenario for all the labs. So we have a corporation called ACE Corporation. It's a SaaS provider that has a presence in AWS, Azure, and GCP. They have three key teams. They have the app team, the networking team, as well as the security, along with two business units, which are BU1 and BU2 that are highlighted in the BU1 is highlighted with the yellowish color, whereas BU2 is highlighted with the purplish color. They engage with call center partners who connect to ACE's SaaS application to run BU1's ML data analytics. They are basically referencing that there is a connection between a call center, an on-prem partner that manages their call center, and to an analytics application that runs analytics inside GCP. There are also some legacy applications within the data center that require connectivity to the multi-cloud environment, and those will actually be decommissioned soon. Okay, so now that we've explained a bit on the scenario, so in a nutshell, we have two business units, and there are some external connectivities, one to the call center from GCP and one to some legacy applications that live in the data center. A bit more details. So all the apps, all the workloads in AWS and GCP, AWS and GCP have public addresses and as well as private addresses, obviously, whereas the ones in Azure are databases, thus they have private addresses, as we do not generally expose those to the internet. All the workloads also have a basic HTTP server running, except the databases. The way the IP schema has been done is that AWS is 10/8, GCP is 172.16, and Azure is 192.168. The third octet of all spoke ones is 211. So as you see, this is spoke one. Again, AWS is always going to be in the 10 space, so it's 10.1 in this example, and the third octet is 211 versus the other spoke 2 is going to be 212. Similarly, here in GCP, we have only one spoke, so it's going to be 211. In Azure, we have 211 as well as 212. Okay, you can access the instances in AWS and GCP. So you are able to access those. So let's look at lab number 1, and let's try to see what's the requirement. So it says the infrastructure was segmented recently into two network domains, BU1 and BU2. Again, BU1 is the yellowish color, BU2 is the purplish color. And here you are given the IP addresses. Obviously, if you have a lab setup, please make sure to use the IP addresses that are within your lab setup. I'm using the IP addresses that belong to my setup. So the idea is let's try to verify segmentation, right? So we want to check that this is in yellow, for example, and this is in purple. And again, it applies, you have 3 yellow spokes and 2 purple spokes across the whole setup. So we can try to, for example, to do pings And we can check which gateways have the routes to 10.1.2.1, and I'll explain what all of this means. Again, if you have a lab setup, please feel free to pause and go through your lab before I take you through the solution. Okay, so let's look at this together. Okay, so there are multiple ways we can verify that this segmentation actually is working. So I am on B1 front end, and I might want to actually ping. So if I look at my IP address first, this is 10.1 to 11.45, which is what is expected. And I can ping 10.1 to 12.40, and the ping does not work. Now, the ping does not work because this is the expected behavior. They are in two different network domains, right? So let's look at, they can also do a curl. This is also not going to work, but just to show different traffic types. Now, if we go to the Copilot, sorry for that. And if we go to Copilot, what we can see is if we go to network segmentation, you can see that there are on the overview. Sorry, my apologies. I'm looking at the wrong Copilot. I was the one I was showing you. So again, network segmentation, you can see that you have two network domains, BU1 and BU2. You can also clearly see that there is no line between the two. You can also see which, for example, in BU1, you have AWS EU West 1 spoke 1, whereas in BU2, you have spoke 2, right? And again, because there is no connection policy between the two, thus there is no leaking of routes and thus no communication. This again shows the same thing without going into which spokes belong to which domain. And even you can see it here, BU1 and BU2, you can see which spokes. There are two spokes in BU2 as we expected, and there are 3 spokes and one external connection in BU1. And notice there is no connected to, so each of these domains is basically segregated. Right. And another thing we can do is we can go to another very nice tool, which is Cloud Routes. And we can ask Cloud Routes to say the name, the gateway contains spoke. So we're looking at all of the spokes. Sorry, just a second. Yeah, so again, we're doing the gateway contains spoke. This will help me filter all the transit gateways, okay? And we can forget about the egress ones for our discussion. And I can look to say who has 10.1.2.1.0. And you will automatically see, if you go back to the diagram, this will help us a lot. 10.1.2.1.0 is in BU1. BU1 has 1 spoke, 2 spokes, and 3 spokes. Thus, these 3 spoke gateways are the ones that have the prefix. So you can see AWS EU West 1 spoke 1, which is this one, EU West 1 spoke 1, and Azure US East spoke 1. Again, this is the Azure. This is also in the yellowish color, in addition to the GCP spoke 1. These are the 3 gateways that have the 2.1.10.1.2 211 route within them, right? And this makes perfect sense. Now, if I were to search for 212, and if you realize 212 is the one with the BU2 mobile app, the VPC within which the BU2 mobile app resides, it has 10.1.2.1.2.0. You see that there are only two gateways that will have it because they only belong to BU2. So you can see that there are two gateways. One of them is in AWS Spoke 2. This is AWS Spoke 2. And the other one will be in Azure East US Spoke 2. Okay, this is again another way to prove that this segmentation is actually happening. If you want maybe another thing to look at, you can go to the Spoke gateways or the transit gateways, my apologies, and look at, for example, AWS, and look at the gateway routes. If you look at the B1, you are not going to find the 212 route. You're only going to find the 211. If you look at BU2, you are only going to find the 212, but you are not going to find the 211 route. Okay? So these are different ways to prove segmentation. Now, this is basically everything we will need to do in lab number 1. Okay, so I've made a change where I configured a connection policy between BU1 and BU2, and we need to see how it affects the environment in different ways. So if you remember what I did previously, a ping to 10.1.2.40, it failed. Now that ping actually works. Again, I'm pinging from BU1 front end to BU2 mobile app. So I'm pinging now across network domains. And if I do a curl, you can see that I return v23 is awesome. So this proves that there is connectivity across domains. If I were to go to the network domains page, now you can see that BU1 is connected to BU2 and BU2 is connected to BU1, right? So you're able to see that you can edit even and make a change, but basically BU1 connects to BU2, and it mentions again connectivity is bidirectional. Another way to see it is if you go to the overview. Previously, we were not seeing any arrows between the BU1 and BU2. Now we can see there is a multitude of connectivity between both of these. For example, if I point to Spoke 2, you can see all the connections, and again, the same thing if I do on the other Spoke. So you can see there is full connectivity, or if I go and now you can see a curved line showing that there is indicating that there is a connectivity between BU1 and BU2. Another thing we can look at is we looked at cloud routes previously. And the check we did was 10.1.2.1.1, right? And what we did, we filtered it by Spoke. So it has to be only a Spoke gateway. And we can see now that we have 5 gateways that have the 10.1.2.1.1 prefix. And if you look at the diagram, we only have 5 spokes. So all of the spokes now actually have the 10.1.2.1.1. So if I look at, for example, AWS Spoke 1 is very logical. AWS Spoke 2 is something we need to look at. So this is AWS Spoke 2. And if I open it, I look at the 6 more, I am able to see 10.1.2.1.1.0. Okay, again, if I'm looking at another one, which is BU2DB, which is the Azure Spoke 2, this is Azure Spoke 2. So this is 10.1.2.1.1.0, again, showing for the Azure Spoke 2. Okay, so these are some different ways. If you look again, if you want to go the transit route and look at any of the transits, if you look at gateway routes, if you look at VU1, for example, now inside VU1, you will see 10.1.2.1.1 as well as 10.1.2.1.2.0. Both of these prefixes will show up as a result of the connection policy. Final thing we can also do, if you look at this, any spoke gateway, if you want to go that route, you can also go there. And now inside the AWS spoke 1, you should see the 212 route, which is 10.1.212. Obviously, 10.1.2.1.1 is actually a local, but we now see 10.1.212 inside spoke 1. So these are the different ways by which you can verify the effects of a connection policy. We did the pings. We looked at the network domains, if the domains were connected or not. We looked at, we also looked at the cloud routes to see the changes for the different routing tables. And we looked at the transit gateway route tables. And we looked at a spoke gateways routing table.